We're going to look at our homework on page 59. It says the slingshot drops riders 27 meters from rest before slowing them down to a stop. How fast are they moving before they start slowing down? The wording of this question is tricky. Okay, it's not so much, I mean, the physics might throw us off too, but I don't know, for me it's not so much the physics that's difficult about this, it's the reading that's difficult about this. It's understanding what they're trying to ask. I'm going to draw a picture of this, okay? You don't need to draw a picture if you can visualize it without, but I just want you to understand what's going on here. We have a slingshot ride here, okay? The slingshot drops riders. Riders fall from the top of the slingshot 27 meters before slowing them down to a stop. So this is how far they drop. They free fall 27 meters before slowing down and stopping on the ground. This is the falling portion. This is the slowing down portion. What you have to understand here is that this slingshot is not 27 meters high. The person or the people fall 27 meters and then they start slowing down. Remember that question that we did before the break where the car accelerated at a certain rate and then went at a constant velocity and then slowed down and we were looking for the displacement? Do you remember that question? That was like 3 problems in one, really, right? This would kind of be like 2, where we're accelerating, we're speeding up during the fall portion, but then we slow down during this portion. Does that make sense? Now, in the end, all we're asked to analyze is this, the falling portion. But what you got to recognize here is that VF, because it's 2 stages like this, VF for the first problem is not 0. It's not stopped here, right? It starts at rest, and then it speeds up, speeds up, speeds up to a certain speed right here, which is what we're trying to find. The speed we're moving at this point, and then it slows down and stops right here. Don't make VF 0. Okay? Don't make VF 0 because it says it's slowing down and eventually stopping. What do we got here? We have a displacement of negative 27 meters. Why negative? Why negative? Danny? Because it's going downwards, right? Good. Negative 27 because it's going downwards. What else we got? VI, I think, is 0 because it starts at rest. Right? It drops. If it throws them down, VI is not 0. But if it drops them, VI is 0. We don't know what VF is. We know what VF is down here in the second problem, but we're not analyzing the second problem. We don't know what VF is here. That's what we're trying to find, right? How fast is it moving at the end of the speeding up phase? How fast is it moving at the end of the falling phase? Anything else we have? Read between the lines. Think about what we did yesterday. Anything else? Yep.
The acceleration.
Yeah, it's accelerating because of gravity. In the absence of air resistance or other forces, the acceleration will always be negative 9.81 meters per second squared. Some of you may call it A. That's fine. Some of you may call it G for specifically the acceleration due to gravity. It doesn't really matter at this point. Okay, this is Group B problem, right, because it's accelerating. Which equation from our Group B list do you think is the one we're going to try? Yeah, go ahead, Jacob.
VF squared, VF squared.
Yeah, I'd probably go VF squared is equal to VI squared plus 2AD as well. Okay, what are we solving for there? VF, right? VF. How are you going to get VF by itself? This is about as easy as it gets rearranging. Okay, it's harder to solve for A or D in this one. How do you solve for VF here? It's almost by itself, not quite. William, what do we do? Yeah, it's VF squared. We got to square root the other side. So it becomes the square root of VI squared plus 2AD. Now VI is 0. I'm just going to X that out because VI is 0. VF is the square root of 2 times negative 9.81 times negative 27. Negative 9.81 because it's speeding up in the downward direction. Negative 27 because it ends up down below where it started. I'm going to pull out the calculator and we'll work through this together. We're going to calculate what's inside there first. 2 times negative 9.81 times negative 27. You got to get those negatives, right? If you only put one of those negatives in, you're going to get a negative number here, and you're not going to be able to square root it. So you got to get all of your signs right. Let's square root that now. 23.01, 23.02, or we should, by rights, round it to 2 digits. I have 20. This is 2 digits. 27 is 2 digits. 9.81 is 3 digits. My final answer should be 2 digits. Final answer is always the least precise piece of data. Right? Make sense? How many people got 23 there? Okay. You didn't get 23. Does it make sense where you made your mistake? Anybody want to tell me where they messed up on it? Yeah? You said VF is 0? Okay. I'm not surprised that I'm sure you're not the only person to have made that mistake. That's kind of what I was getting at with this diagram, right, is that when we read this, it is, like I said, it's confusing wording, right? When we read this, if we're not really paying attention or having a little bit of trouble with the wording there, then it becomes really easy to say that VF is equal to 0. Does it make sense why it's not 0, though? Okay, good. Let's take a look at another example then. 1.19 on page 60. This is similar to the one we did yesterday. Not exactly the same, though. It says a clown throws a ball upward at 10 meters per second. How long does it take the ball to return to the clown's hand? So let's picture what's happening here. The clown is at ground level. The clown throws the ball upwards at 10 meters per second. What happens to the ball as it goes upwards? Slows down, and then it stops, and then it speeds up. The acceleration the whole time is what? It's negative 9.81 as it goes up because it's slowing down in the positive direction. It's also negative 9.81 as it goes down because it's speeding up in the negative direction. So for this whole time, we're going to say A is negative 9.81 meters per second squared. Now, in question A, we're looking for the time that it takes from the clown's hand, to the clown's hand from the maximum height. This is maximum height up here, right? So we're looking for how long does it take the ball to fall from the maximum height. If we're only analyzing this part of the trip, from the maximum height back down to the clown's hand, there's another piece of data we have there, Ben. You could. Yeah, you could. That's not where I'm kind of going with this right now. Good? Yeah. If we're analyzing just the trip down, we're going to come back to that, okay, Ben? Because I like what you said there. It's just not the way that I was going with this, okay? If we're analyzing just the trip down, we're going to say VF is equal to 0 because it stops and then comes down. And we'd be looking for the time, right? Is that all that we have? And we're looking for the ball's final velocity as well. I don't think I can do it this way, can I? Ben, I think we're going to have to go to your way. Yeah, I think we're going to have to. So I'm thinking of all the group B equations, and I don't think there's any that I can use to find anything for the trip down. Yeah?
You could find a final velocity by measuring the first half. So you set final velocity as 0 meters per second because when it reaches the top of its...
Oh, yeah, okay. Yeah, okay. Yeah, but that's not just doing this, right? That's doing something else in addition to that, right? So just doing this, just analyzing the trip down, I don't think there's a way to do this. So we're going to go back to Ben's way. We're going to, instead of analyzing just the trip down, what we're going to do is analyze the whole trip. Why? Because that didn't work for me. Okay, remember what I said? It's okay to try something. What happened when I tried something there? I couldn't get an answer because I didn't have enough givens. So what do I got to do? Try something else. Try again. I didn't get a wrong answer. I just didn't get an answer. So if I'm going to analyze the whole trip up and down, we would say VI is equal to 10 meters per second. We would say A is equal to still negative 9.81 meters per second squared for the whole trip. Anything else? Oh, there is one more given here. Yeah? Good. If you're analyzing the whole trip, the displacement is 0. How come? Starts at the clown's hand. Where does it end? Clown's hand. It's like running, remember on day 1 of Physics 20, running around the track? If you ended up where you started, the displacement was? If this ball ends up where it started, the displacement is? 0, right? Okay, let's find, oh, you got to be so careful with this. Man, this is a nasty question. Let's find T here. I don't have a way to find T there. No, I don't think I do. Holy cow. What do you want to do, Sean? Yeah, you could use the quadratic formula, but some people in this class don't know what you're talking about right now, so we're not going to try that. But at least I'm not going to try that. Did you do that? No? No? But you could, yeah, you could. Okay, that's okay. That's okay. We have something else that we're looking for, right? So let's try getting that something else. Let's get VF. Let's say VF squared is equal to VI squared plus 2AD. We're looking for VF here. It's the square root of VI squared plus 2AD. Oh, I think this is going to work for us. VF is the square root of 10 squared plus 2 times negative 9.81 times 0. Do you know what you're going to get if you do the math there really, really quick? Lightning fast this is how smart I am. Lightning fast calculation here, we get 10 meters per second. Okay, now, how was I so quick with that? Well, 2 ways. One, because 2 times 9.81 times 0 is 0. Square root of 10 squared is 10. Now, the other way, honestly, the way that I knew that was going to be 10, if I throw something at 10 up and it comes back down, how fast is it moving when it comes back down? 10, right? I knew it had to be 10 when I started. Okay. By the way, that's the final speed. That's the final speed. Now let's get the time that it takes. Let's try this one. D is equal to VI plus VF over 2 times T No, I don't like that one. Yeah, no, that'll work. Yeah. Did you write that down and then erase it because I erased it? Oh. Do you know what, guys? This question illustrates like a really important thing for you guys to understand. Sometimes when we do questions, we're not sure exactly how it's going to go, right? Like when I'm doing this question, like I'm doing this question with you. And when I'm doing this question, I'm not sure how I'm going to get the answer right off the top. That's okay. That doesn't scare me. I'm confident that I'm going to be able to solve this question. It might take me a couple minutes. I might have to try something else because the first thing I try doesn't work. That's okay. That's the way it goes. Okay, that's the way it goes. So don't be afraid of that. Okay, even I have to do that sometimes. Okay, let's say that T now is equal to delta D over VI plus VF over T. Over, this should be 2, shouldn't it? VI plus VF over 2. Now, this was analyzing the whole trip. This is analyzing just the trip down. The displacement over the trip down is, oh, we don't know that.
You can just do the whole trip. No, from the maximum.
Man. Yeah, my problem is, though, I am going to end up getting an undefined number here. When I say 0 displacement over 10 plus negative 10, 0 over 0. See what's happening there? So let's see here. Yeah, let's say, oh, let's make this way easier. Hey, it doesn't work. Doesn't work. Let's try something else. A is equal to delta V over delta T. I don't know how I missed that one. We're still analyzing the trip down here. VF minus VI. The final velocity is? No, it's not 10 meters per second. The final velocity is? Nope. The final velocity is not 10. It's not 5. The final velocity is? Nope. For the trip down, the final velocity is? Negative 10. That was the final speed that I just got there, right? Final speed is 10. The final velocity is negative 10. Oh, my goodness. The initial velocity for the trip down is 0, and the acceleration is negative 9.81. So we're going to say negative 10 divided by negative 9.81. That's going to give me 1.1, I'm going to say. 1.0. Okay. To, how many digits should I go to? Should go to 3 digits, right? 4 digits here, 3 digits here. So how many is it to 3 digits there? 1.02. Man, that's a hard one. That's a hard one. Yeah, it is. Do you know what this? Most questions that you get aren't going to be that hard, but some will. Okay, and to put it bluntly, that's life. Sometimes life is going to be hard. Okay, when you come across something that's difficult, don't give up on it. Keep working at it. That's what we did, right? That was tough. Like, we all had a tough time on that one. I had a tough time on that. What did I do? Kept going. And what happened? We got an answer. We got a correct answer because we kept working on it. All right, I'm going to give you a couple more questions to do here. Oops. Questions A and B for question number 1 on page 60, please. All right, if that question is good, then I'm going to refer you to page 63. Good news is, hey, I'm not going to make you do all of these questions. There's 16 questions on this page. I'm going to only make you do 15. Questions 2 to 16. You don't need to do question number 1. That would be way too much to expect you to do all the questions. Questions 2 to 16 we're going to work on for a little while in class here. We'll see how well it goes, and then we'll decide, depending on how well it's going, what we end up having for homework here, okay? It won't necessarily be all of these questions.